So we've been working extensively with these quadratic functions. We've been graphing them. We actually factored them earlier on. Now we're going to talk about what about quadratic equations, and we're going to solve them. And some of the methods for solving are methods that we've already been using or we have studied already. We're going to look at two methods here in this lesson today. The first one is solving the quadratic equations by graphing. We just finished studying how to graph them. So let's look at the details of our notes here. A quadratic equation, right, can be written in standard form as ax squared plus bx plus c equals 0. There's that equal sign to make it an equation. We've been working with functions lately. Y equals the standard form. Now we're working with it as an equation equals 0. You can solve a quadratic equation equal to 0 by a variety of methods. We're going to look at two today. One way, the first way we're going to look at how to solve a quadratic equation with that equals 0 piece is to graph the related function y equals ax squared plus bx plus c. Okay, so look at our notes here to the right. Most of our quadratics are going to have two x-intercepts, and therefore they're going to have two solutions. That's right. Those x-intercepts are going to be our answers or our solutions. We can have some parabolas that only touch once and only have one solution. And then very rarely, it's going to be too high or maybe it's too low if it's an open downward parabola and has no real solutions. We can talk more about that as you have questions. So no solutions if it's not crossing our x-axis. Those solutions we just talked about are called zeros or roots, and they represent the x-intercept in our function. So if I graph it and I just look for those x-intercepts, I have my answers or my solutions to the quadratic equation. Starting with number 1, graph the equation y equals negative x squared plus 8x minus 15 on the axes. Same directions as we've seen on Delta Math before. You must plot 5 points and only 5 points, and those must include those roots and the vertex. Remember, the roots are x-intercepts. So using the graph, let's determine those roots of the equation negative x squared plus 8x minus 15 equals 0. So we're going to graph the function, and it's going to determine the roots or the solutions to the equation equal to 0. You see that? Let's review a little bit. If we were to graph by hand, we would find the axis of symmetry, which is x equals negative b over 2a. In our equation up here, this a is a negative 1, b is 8, and c is negative 15. So we have a negative from our formula, 8 over 2 times negative 1, or our axis of symmetry would be at positive 4. Next, you can find your vertex by plugging in that axis of symmetry value into your quadratic function. So if I had y equals, it was negative, plugging in the 4 squared plus 8 times 4 minus 15. When I evaluate all that, I get a positive 1. So that means our vertex is going to be 4, 1. So let me sketch a little bit here. We have our axis of symmetry was at 4. Our vertex was at 4, 1. I could use the 1, 3, 5 rule. Our a is a negative 1, so I would go over 1, down 1 on each side, over 1, down 1, 2, 3, and that would build my quadratic. So let me graph it to you on the calculator. Just wanted to review how we would do that by hand. Opening a graphs page, we had negative x squared plus 8x minus 15. I'm going to turn on the grid. So view is number 2, grid, and lined grid is 3. And I can see those ordered pairs. Let me use the trace tool. 5, graph trace is 1. Come up here. And we can see our maximum there, it's labeled in the bottom right, is 4, 1, just like I found by hand. Over to the left, that 0 or x-intercept or root is at 3, 0. And on the right side is at 5, 0, exactly like we have graphed here. So we had our vertex at 4, 1. We have our roots. Let me go ahead and connect our parabola here. Our roots, our x-intercept was at 3, 0, and the other one was at 5, 0. So back to the question, using the graph, determine the roots of the equation. The roots were 3, 0, and 5, 0. We're just going to list our x values here, 3 and 5. Let's try again with number 2. Graph the equation y equals x squared plus 6x plus 5 on the set of axes. You must plot 5 points, including the roots and the vertex. Using the graph, determine the roots, or x-intercepts, that would solve the equation x squared plus 6x plus 5. So again, just reviewing, axis of symmetry, negative b over 2a for this one would be negative 6 over 2 times 1, or I'm going to have negative 3 as my axis of symmetry. My vertex, when I plug in that negative 3 into the function, negative 3 is getting squared plus 6 times negative 3 plus 5. When I evaluate that, I get a negative 4. So our vertex is going to be negative 3, negative 4. Negative 3, negative 4, plotting it there. Even show it in pink. When you graph it on Delta Math, must include this point, vertex negative 3, negative 4. Then I could use the 1, 3, 5 rule. Our A is an understood 1, so I'd go over 1, up 1, over 1, up 1 on both sides, over 1, up 1, 2, 3, and I'm hitting our x-axis, or those are going to be my roots. Tracing my parabola here, we have a root or x-intercept here at negative 5, 0, and the other one is right here at negative 1, 0. So to answer our question, use the graph to determine the roots. We had negative 5 and negative 1. Let's graph it on the calculator to show it there. Control Doc to add a new page. Adding graphs. Our equation was x squared plus 6x plus 5. Graphing, going to turn on those grid lines, 2, 6, 3. And using my trace tool, graph trace, arrowing over to the left, there's my x-intercept, 0, root, all means the same thing, negative 1, 0, got that. Our minimum, or our vertex, is negative 3, negative 4, got that. And then our other 0, or x-intercept, negative 5, 0. So up to you how you want to graph it. I do encourage you to just practice doing it by hand. As I mentioned in the other lesson, sometimes we have quadratic graph questions in the non-calculator section, so it's important that you are comfortable and feel familiar with some aspects of the graphs without the calculator. So that is one way we can solve a quadratic equation, is by graphing. The second method we're going to look at today is by factoring. So before we learned how to graph, we actually factored some polynomials. So we're going to pull that concept back in. If you need to review those lessons, you can go back. You still have access to those on Delta Math. So solving quadratic equations by factoring, and that's what we have here on our notes. Another method to solve a quadratic equation is by factoring. A polynomial is in factored form when it's expressed as a product of one or more binomials. So if you think back to when we studied how to factor, we were breaking it down into the original pieces that were multiplied together. So oftentimes we had those parentheses left over from that factored form. When a quadratic is written in factored form, we can set each factor equal to 0 to find those x-intercepts. So that is our goal, get it into factored form, and then our next step is going to be to put each factor equal to 0 and solve little baby equations to get our x-intercepts. I'll show you on page 2. Page 2 has those steps written out. Number 1, we're going to make sure that our quadratic is in standard form, meaning that it is equal to 0 before we begin. Number 2, check for a GCF. Sometimes our numbers are really big and we can actually make them smaller and easier to work with if we just eliminate a greatest common factor. Step 3, we're going to factor whatever's left over that cannot be reduced with a greatest common factor. And then number 4, we'll set each factor equal to 0 and solve. So number 1, solving for all our values of x by factoring. This is in standard form. It is equal to 0. It's ax squared plus bx plus c equals 0. So we are ready to go for step 1. Step 2, checking for a GCF across all of our terms. No. So let's factor, and we're factoring this left side, the x squared minus 11x plus 10. Remember, we want to find the factors of 10 that add up to a negative 11. So I'm going to put some scratch work over here. So factors of 10, 1 and 10, 2 and 5, that's pretty much it. So which of those factors could we use to add up to negative 11? Of course, 1 and 10. However, we need to make them both negatives so that they multiply together. Two negatives multiply to make a positive 10 and add together to make a negative 11. So you may want to rewrite this 3 terms into 4 terms and use grouping. However, your fast track method for factoring this is going to be x minus 1 times x minus 10. I take those 2 values that I found and throw them into my binomials, respecting the positive or negative sign there, and I'm done. Okay, I have factored it. Let's look. Step 4, set each of those factors equal to 0. So I'm going to take x minus 1 and set it equal to 0, and x minus 10 and set it equal to 0. I'm going to solve each of these to reveal my x-intercepts. Okay, so this is going to be easily solved by adding 1 to both sides. My first root x-intercept 0 solution is positive 1. My other one is going to be positive 10. I'm going to show you what that looks like on the graph, just so you can see we are doing the same process, but on this one, we are showing it by solving with factoring. So let's grab the calculator. All right, let's graph this one. The related function would have been y equals x squared minus 11x plus 10. Showing our grid lines 2, 6, 3, lined grid. And let me turn on trace, graph trace. As I move over first 0, you can see it's labeled as 1, 0. What was one of our solutions? 1. Let me arrow over. It's going to hit our minimum or our vertex there and slide back up. The other 0 or root labeled down here at the right is 10, 0. Get that to highlight. There we go. 10, 0. And what was our other solution? 10. So we have 2 different methods here. We're going to learn a couple others in the next lesson, but we could graph it and visually see where those x-intercepts are. We can also factor it and get those x-intercepts. We do need to know how to do both methods because both methods are tested in Algebra 1. Okay, so for number 1, the answer is 1 and 10. 2 solutions because our parabola crossed at 2 places. Number 2, x squared minus 11x plus 13 equals 3. Did you notice that? Equals to 3. Not in standard form yet, so let's subtract the 3. X squared plus 11x plus 10 equals 0. This looks familiar, but it's not exactly the same. I know, I wish it was. Let's look for the factors of 10 that add up to positive 11. Do you know what it should be? Positive 1 and positive 10, so go ahead and factor that. The factors are x plus 1 and x plus 10. Solve by setting each of those equal to 0. In the first one, x plus 1, we would subtract 1 from both sides. Our first solution is negative 1. In the second equation, I would subtract 10 from both sides. Second equation, second solution, negative 10. Number 3, x squared minus 20x plus 72 equals negative 3x. Not in standard form, so let's add the 3x over. It is going to combine with the other like term on the left side, the negative 20x. So our new standard form quadratic, x squared minus 17x plus 72 equals 0. So we want the factors of 72 that add up to a negative 17. Let's do some scratch work over here. All right, factors of 72. 1 times 72. I don't think that's going to be it. You could do 2 and 36. No. 3 times 24. Closer. What about 8 and 9? Okay. So now we would both of them would need to be negative. So the two negatives multiply to make a positive, and they add up to a negative 17. We can quickly create those factors by plugging those numbers in: x minus 8, x minus 9. Set each factor equal to 0. So x minus 8 equals 0, x minus 9 equals 0. And solve each of those. On the first one, x minus 8 equals 0. So add 8 to both sides. Final answer, positive 8. Second equation, I would add 9 to both sides. So final answer, x equals positive 9. Two answers, 8 and 9. If I was to graph this, the parabola would cross at 8 and 9 on the x-axis. Number 4, I can already tell is not into standard form. So we'll need to add 3x to the other side. I'm also going to need to subtract 3 on both sides. Notice I'm going to go ahead and do both of these in one step, and I'm going ahead and lining them up on the left side with their like terms. So our new standard form quadratic, x squared plus 6x plus 5. 8 minus 3 is 5. All right, the factors of 5 that would add up to 6. Woo! That's going to be a tough one. 1 and 5. Yes. All right, so let's build that out. X plus 1 and x plus 5 equals 0. I'm going to set each of those equal to 0 and solve each of them. X plus 1 equals 0. I would have to subtract 1 from both sides. My first solution is a negative 1. X plus 5 equals 0. I would have to subtract 5 from both sides. Second solution, negative 5. So this parabola, if I graphed it once in standard form, it would cross at negative 1 and negative 5. Number 5, let's go ahead and put that into standard form. I would need to subtract the 4x to the other side. We would have x squared combining on the left side gives us negative 7x. There is no constant term, equals 0. This looks odd, doesn't it? It looks really weird. Okay, let's not forget what the second step is at the top of our notes is look for a GCF. What do these guys have in common? So we can still factor with a greatest common factor. They each share an x. So as I remove an x from each term, the remaining binomial is x minus 7. That is considered in factored form. I have broken it down and I cannot break it down any further. So let's set each factor equal to 0, still following the same steps. There are two factors here, the x and the x minus 7. So setting x equal to 0 does reveal our first solution. It is crossing at 0 if I was to graph it. The other one, x minus 7 equals 0. When I solve it, I would add 7 to both sides, revealing my second solution, positive 7. So 0 and 7 are both solutions here. Just number 5 looked a little bit different. We used factoring of a GCF to factor the polynomial, and it crosses at 0 on the x-axis. Really not anything too crazy. Number 6, putting it into standard form, adding the 3x to the other side. We have x squared plus 3x equals 0. This looks very similar to that last problem. Do they have a GCF in common? Of course, the x, when I remove it, I get x plus 3 left over. So there are two factors here. Set them both equal to 0. And solving each of them, the first one's already solved. X equals 0. The other one, when I subtract 3 from both sides, I get -3 as my other x-intercept. If I was to graph the related function, it would cross at 0 and -3. Number 7, we would need to add 4x to both sides. Our new polynomial in standard form. Actually, did you notice that 4's are also canceling on the left side? So I have x squared minus 25 equals 0. This one looks weird as well. Is there a GCF we can work with? No, they don't share x's in common. They also don't share any numerical values in common. However, do you remember what this is? This is a difference of perfect squares. If you recall, the formula was if you had an a value squared minus a b value squared, it would factor perfectly into a plus b times a minus b. So in our problem that we have here, we have x squared. X is being squared. Minus 25. 25 is a perfect square, 5 times 5. So this one factors really easily into x plus 5 times x minus 5. I would set each of those factors equal to 0 and solve, and you betcha I'm going to get a positive and -5 as my final answer. So again, two solutions there. If I was to graph that related function, y equals x squared minus 25, it's going to cross the x-axis beautifully at -5 and +5. One last problem, number 8, we would add the 2x. And I would also have to subtract 5 from both sides. Our new polynomial, x squared, that 2 x's canceled out, and we were left with -4 minus 5 is -9. Again, is our GCF here? No. It's another difference of perfect squares. X is being squared. 9 is a perfect square, 3 times 3. And so this is going to factor into x plus 3, x minus 3. Just knowing those special cases that we studied in our factoring lessons earlier. Set each of these equal to 0 and solve. And of course, I'm going to get a positive and -3 as my final answer. If we were to graph it, just like the other one, if we graphed y equals x squared minus 9, the polynomial when it's in standard form, it's going to cross at -3 and +3. So solving quadratic equations, we can do it with some methods that we've already been studying. Starting with graphing, we can visually look at the graph and see where it's crossing the x-axis. We just revisited some of those things that we did just a few lessons ago, putting it on the calculator or doing it by hand, finding the vertex and the roots there. Second method for solving a quadratic equation is to factor it. And so following those rules of factorization and then setting each factor equal to 0 to find those x-intercepts. Both are giving us the same information, just two different methods. We do have to know both methods because we're going to see questions or student work or errors or things like that to analyze on each of these methods. We'll actually look at 2 more methods for solving quadratic equations this week. So look forward to showing you those, and I'll see you in class, guys. Please let me know if you have any questions. See you there.